Irodov problem number 1.240. Demonstrate that in the case of a thin plate of arbitrary shape, there is the following relationship between the moments of inertia I1 plus I2 equals I3, where sub-indices 1, 2 and 3 define three mutually perpendicular axes passing through one point with axes 1 and 2 lying in the plane of the plate. Using this relationship, find the moment of inertia of a thin uniform round disk of r radius and mass m relative to the axis coinciding with one of its diameters. So this is actually a very standard derivation. This is called the perpendicular axis theorem. So let's say we have a arbitrary shape, okay, and let's say there are two axes. Let us say that these two axes are in the plane of the plate. Now we have a third axis which is perpendicular to both of these axes, okay, and so basically this third axis is perpendicular to the plane of the plate, okay. Now in the question it says 1 and 2, they are in the plane of the plate, and the third axis 3 is perpendicular to both 1 and 2. For simplicity or for our convenience, let's assume this is the x-axis, this is the y-axis, and this is the z-axis, okay. All right. Now what we need to establish is I1 plus I2 is equal to I3. This is actually called the perpendicular axis theorem. This perpendicular axis theorem is actually only applicable for laminar objects. Laminar objects means they are in one plane, so they do not have any thickness, okay. And if I1 and I2, which are moment of inertia about two perpendicular axes, are known, which lie on the plane of the laminar object, then we can find out the moment of inertia about an axis which is perpendicular to the plane of the laminar, okay. So for this one, let's assume that there is a small mass m1, okay, and m1 is at coordinate x, y. So it means what? It is x distance. So this is x distance from the y-axis, and it is y distance from the x-axis, okay. So obviously this is a perpendicular, this is a perpendicular, okay. So for this m1, we can write di about 1, okay. So this m1 is at a distance y, so we can write m1 y square is the moment of inertia of the small mass m1 about axis 1, okay. Similarly, di2 is moment of inertia about axis 2. It is at a distance x from axis 2 m1, so m1 x square is di2, okay. Now to find out the moment of inertia about axis 3, which I will call di3, what do I need to know? I need to know the perpendicular distance from axis 3, right? Now how much is this perpendicular distance? If this distance is x, this is y, this is a right angle triangle. then that perpendicular distance, let's suppose this is r is nothing but root over x square plus y square. So di3 is m1 r square, or we can write m1 r square is x square plus y square, which is nothing but m1 x square is di2 and m1 y square is di1. So we got this. Now this is only for one point mass which had a coordinate xy. So to get the moment of inertia of the entire body, I would integrate over the entire mass. So if similarly different masses are taken all over the surface of the body, then I will just integrate everything over the surface of the body, and this will be nothing but I3, this will be I2, and this will be I1. So hence we proved I3 is I1 plus I2. Okay. All right. Now the next question is, let's say if I have a disk, okay, of radius r and mass m, and I know the moment of inertia about this axis, which is perpendicular to the plane of the disk. Okay, so this I is known. So let's say this is IZ. Okay, now we have to find the moment of inertia about an axis which is in the plane of the disk. Okay. Now let's take another axis which is also in the plane of the disk but perpendicular to this. Okay. Now this is symmetric. So let's say this is x, this is y, this was z. So IZ I know. Using the perpendicular axis theorem, can I write IZ is IX plus IY, moment of inertia of this plate around X, moment of inertia of this plate around Y. Now IX and IY are both same, and I can just write 2 times IX. And IZ is given as half m r square. This is known. Okay. So Ix is nothing but 1 by 4 m r square. Okay. So that's a very simple and easy application of the perpendicular axis theorem. Now only thing to remember here is this is applicable only to laminar objects. So if it is a 3-dimensional object, we cannot use perpendicular axis theorem. And for laminar objects, if 2 axes which are perpendicular to each other must lie on the plane of the object, and then we can find out the I about, or the moment of inertia about an axis which is perpendicular to both those axes which lie on the plane of the object. Okay, so that's our solution.